Hi everyone. I hope you are all well and ready for the first discussion session of ARE 107. So today we're going to introduce ourselves with the statistical package R that we will be needing in this course. So I hope you guys have already downloaded the software, and if not, then you can pause the video and check the syllabus and you will find two links for R and R Studio. And after installing them, when you're ready, when you open R Studio, you are going to see 4 panels in your screen. So I know some of you are already familiar with R, but I'm still gonna briefly go over and introduce you to the panels very quickly for those who are just beginning to use this software. So in the upper left corner, we have the source panel. So this is the place where we will mostly be writing our codes and saving the scripts as a text file from here. And this is the console panel. Here we are usually gonna get the results of the codes or commands run in the source panel, or we can just directly write the commands here and see the result instantly. And it's particularly useful when you're just interactively playing with your data. And then you have the environment panel where you will be able to see the variables you have in your workspace. And finally, in this panel, there are some tabs on files, plots, packages, and when we start working along, and we will be able to see how useful these tabs are. So usually when we're starting an analysis, we would usually write down the code here. For example, starting from generating a variable x that takes the value of 1 to 10. And when we click on run, we can see that here is in the console panel, we have the result of, and in the environment panel, we see the created variable that is x, that is an integer of length 10, and these are the objects. We're not going to write down the code here. Instead, we're going to use the code we have in our Canvas folder. So here, yeah. So here, this is the R file, and this is the data file advertising, and we're going to see the commands first. You can either double click on it, or you can also open the command file from file and click on open file. So now, as we can see, we will start with creating some scalars and vectors. So how do we do that? We write down the desired name of the variable. You can write A or whatever you want to name the particular scalar or the variable that you want to assign to, and then write the less than sign or create an arrow with less than sign and a dash, and then you write the value you want to assign. So here we can either put the cursor on the line and click on run, or if we want to run multiple commands, we can just highlight what we want to run and then either click on run, or we press Control and enter all together. In the console panel, we can see that we wanted to create two variables A and B, and this is the integer we have created before. So yeah, so A takes the value of 1 and B takes the value of 2. And in the console panel, if you want to see what's the value of A plus B, we write it print, and then place our function, whatever function we want, in the parentheses. For example, we can also ask for uh, um, the value of a minus b. Let's just see what it is. It's -1 because a is 1 and b is -2. And we can do any other function, any other mathematical function that we want to do and put it into the parentheses after print. So now this is how we can create a scalar. And if we want to create a vector, we are going to assign the value in the same way to some name or variable. Doesn't matter, it can be a name or just any letter. And put the values we want to be there in this parenthesis after C. So if for some reason we are not sure, like whenever we are working with some code, or we are not sure about how the code works or what's the meaning of it, we can also check this out from by like this. This is very easy. I put a question mark here, and whatever the function you are not sure of, write it down and click enter, and you're going to see the help tab has opened, and you will be able to see the description of a particular function or a command. So here it says that by C you will be able to create a vector. So we're not going to highlight the whole thing. And also, as you can see, you can find out the mean value of any variable or find out the summation of two variables. So I'm just going to highlight all of them together and run the code. There we have two variables created that has a range of 3 and take these values. And when we want to see the mean value of y, we have it 20. And if we want, here is the result of the summation of the two vectors we created. This is what we got. So one thing is that the x value was not created in the script. So maybe it would look better if we just get rid of this anomaly right now. So if we want to remove one of the variables, there is another command for it. You just have to, in case you are not aware of which command to use, you can always Google or search here with the question mark, whatever command you were not familiar with. So I know its command, that is rm. And in the parentheses, I'm just going to list the name of the variable. Right now, I just want to get rid of the variable x. So there, it's no longer here. So we have gone through the basic things. And then if we want to create a data frame, then again, we can just name the data frame and then put an equal sign and put the function for data frame. Once again, if we are not familiar with the syntax of a particular command, then we can always search for help here or write down the command for getting help. So in this command, we're basically creating a data frame containing a variable x, a vector x that takes these values, another vector y taking these values, another vector z taking these values. So once we run the code by clicking Control Enter, here we have the data frame. We can either view the data frame by double clicking on it, or we can just click on here to see what are the values in each of the variables, or if we just we just opened another tab in the source panel. So I'm going to go back to my command file. So the other thing is that we can just write down view and write the name of the variable, and that will also take us to the same data frame. So now, once again, if we want to just view it in the console panel, we can print it. Oh, oops. And if we want to see a particular column or row from the existing data frame, we just need to put a $sign and the name of the row or the column we want to see. So let's check this out here. And now we have the values of column Z of data frame T. I'm just going to clean it up for convenience. And let's see if we want to see a particular, let's print it again. And we only want to see the value of the row. So we are not going to change this one because it's a really well organized code. Instead, since we are just trying to see the results and play around, we will do it in the console panel. So we want to see number 2. Oops, let's try something else. I just Googled how to print the row of a data frame in R. There you go. So yeah. So that was the way to get if you want to see the row value of a data frame. Okay, so now if we want to see a particular observation from our data frame, we need to locate which one we want to see. The first one is the number of the row and the second one is the number of the column. So I think instead of this one, if you have written it inside the print, it would have given the same result. Let's try it. And now if you just specify which observation you want to get, the first one is the row, one, and control and enter gives the value of the first row and second row. So we have already seen how to remove a particular variable or object from the environment. Like, once again, because we are going to use another, we are now just going to get rid of whatever we have in the environment. So we are familiar with the command rm. There you go, it's empty now. Let me clean this up as well. I'm just cleaning this up because I need to get a better view of everything, but it's not necessary at all. So now if when working with R, there will be some of during your analysis, the statistical package may not be built in the program. So in that case, you need to install the package and load the package into the memory. So in that case, one thing is you can check from package and see the existing ones and click on it, select it, or, well, there are some things like, okay, this particular package is not usable in this version of R, and we can see the version as well. Or if you know which package you will be using, you can just write down the command and load it from here. So the package PLM is basically the fitted linear module for panel data that you will be familiar in your lectures. Now we're just going to install the package. So you may need to do it often. It's good if you just know how to install a package and use it. Yeah. So yeah. And then now we are going to see that if we want to work with any particular data set, how are we going to do it? So at first, it's really convenient to set up the working directory. Like if you set up a working directory, the software is always going to read the next files from the same place or from the same directory. So one way is you can write down the code and write down the path of your folder, but this is not the path of my computer. So I'm gonna need to change the working directory of my computer. So because I don't want to write the whole address right now, I'm gonna do it from the session tab and click on set working directory and choose directory. And here is my folder where I have the R files. And there, you can see the command is already written here. I'm going to replace it in my source panel or the script file because I will be using it later, and so that I can use it directly from my computer. And then the load command is used to load the particular data. If you already know the name of your data file, you can just write it in the double inverted comma and in the parenthesis. And that is the data file we have. But in case you don't know the name of it, you can just click on this button and you can find the existing files in your working directory, and you can just click on here and you will get your data frame here. And in case you don't have a data file in our workspace, if your data file is in CSV form or Excel or any other format, you can just import your data set and by clicking any of these options. So now, after loading the data, like as you can see, the data has been loaded, and we are going to see the first few observations by using the head command. There you go. In this way, we can get an idea of what we have. So we have variable X, TV, radio, newspaper, and cells. I'm guessing this is the unit of cells depending on advertisement on newspaper, advertisement on radio, and advertisement on TV, and the number of observation. So we can either view my data or the data frame, or we can just double click from environment to see the data. There we have 200 observations of 5 variables. 200 observations and 5 variables. So we have seen our data, and now if we want to get an overall summary or descriptive statistics of each of the variables, we're going to be using the summary command. And let's see what we have here. So we have the minimum value, the first quartile value, the median, mean, third quartile value, and the maximum value of each of the variables. So we can get an idea of what we're dealing with from this command. And now if we want to visualize what we were talking about, what the data is about, we can plot different type of diagrams, and the most common or easy would be checking the histogram of any of the variable. So histogram actually shows the frequency distribution of a variable in particular intervals. So let's see what we have here. Okay, so here is our histogram. Here is, as you can see, we have the plot, and the histogram shows that the frequency of cells in each interval, and it divided the intervals from of 5. And now if we want to plot one variable against another just to see whether there is any correlation, keep a note of that. The correlation doesn't mean causation. You have already seen it in your lecture as well. But if we want to just get a generic idea about the correlation between like how the two variables are moving toward one place or another, so we can just create a scatter plot of that. And as you can see here, one more thing that I would like you to notice, that in each of the functions or commands, we are using the data frame name first and putting the $sign before the name of the variable. And same goes for this one. So since we're creating a scatter plot for two variables from the same data file, we are using the name here. So here we can see that if we have to like get the average of each of the points for the values of TV advertising, we would kind of get an upward sloping trend here. But again, this doesn't mean any causation, like TV advertising created increased sales. We cannot, by this amount, we cannot just create inference from this. So yeah, we're just plotting each of the observation of TV advertising against sales that we have here. Like for 1/90th observation, the sales amount is this, and TV advertising is of this unit. So we're just plotting it here. And finally, if we are about to do any regression analysis for what we have seen here, like we have seen two things here, two plots here. It's just a histogram and the scatter plot. So if we want to see the regression, we want to carry on a regression analysis, and we want to see how much TV advertising is affecting the sales of a product. And in this case, because we don't have any other variable here attached here, we have to be very much careful while interpreting this result. So the lm command means the fitted linear model, like this. For this particular scatter plot, we want to fit a linear, if we want to fit a linear line, how would that be? And in that case, if we fit a linear line, then there will also be a lot of error around here, and we have to hold everything else constant. So let's see what it gives us. So the regression result gives us an intercept and a coefficient of TV advertising. We have a coefficient for TV advertising and a positive intercept. But just viewing the value of intercept and the coefficient gives little information about what we're trying to find out, or whatever generalization we want to do. So we want to see a summary of the result, or we want to check the standard deviation or the distribution of the residual term here. So let's just store, or let's just assign the regression estimated values, or store the results in some other variable here. So here we are just naming it regression of TV, and it will store the value of the regression equation of sales from TV advertising. So here we have a list of tools. There are coefficients, residuals, and I think it will be nicer to see it from the console panel, and we can get it from the summary of the regression result. So we have, this is our formula. And we have the distribution of the residuals. And from the distribution of the residuals, we can interpret, like, the smaller the residuals, the better it is, like it is a better fit to the model, and the larger, it's not a better fit. And then again, we have the value of the coefficients. And previously, we only saw the value of the intercept and the coefficients. Now we have the standard error value. The smaller it is, the better our model is. And then the t value and the level of significance here. And also the significance code is given here. So yeah, that's the summary if we regress sales on TV advertising. And now if we want to see it from multiple variables, we are just like previously we have checked the regression results separately, but now we're just gonna regress and store the results all together. So, and see the summary. Yeah. Here again, previously we just had one explanatory variable, that was the TV advertisement, and now we have more variables, that radio advertisement and newspaper, along with the distribution of the residual and the summary of the coefficients. And we can see that the intercept, the coefficient of radio advertisement and coefficient of TV advertisement are significant here, and there is no star sign. And this is what we got. And also it shows that the newspaper advertisement has a negative impact on sales. But once again, because this is a very simple and basic model, we have to be very cautious about coming to a conclusion about the result of it. So this is what we want to do for today. I hope there will be further explanation on what we have done today in the next few classes. And as we go along with the lectures, and we will be able to see more things using R.